Hello and welcome to Maski Learning and Maski TV. We are here again this evening with Teacher Tandy, of course. So let's do this again, grade 9, for the second lesson as we intervene and help you. Please settle, take your water, have your written pad and your pen so that we can do this math and make sure that we get the math. Nothing. So let's do this together. We are still on graphs. We are still interpreting these graphs, but today we're going to focus solely on how to calculate gradients, which is very important for us to understand the concept of a straight line, because going forward you would need to use the gradient to perhaps draw the graph, even to identify the gradient from the equation. If you can remember in our first lesson where we had an equation of y equals mx plus c, and where most of you were asking what is m, what is the meaning of m. So we are here today to then describe and interpret the meaning of m, the one that you were busy asking. So this is the same m we are talking about, which we call gradient. So at the end of this lesson, you would know how to calculate the gradient of straight line, or when you are given 2 points that you need to calculate the gradient from. And if we have time, we are also going to look at the positive gradient, negative gradient, and undefined, and also zero gradients that we have. So we're going to do all this today. If not, we're going to do it on the other lesson. There's a formula as well that I'm going to take you through the lesson. Okay, so let's see. We are recapping, right? As we said, we had talked about our equation y equals mx plus c. So this is our equation of a straight line, right? Where we had said m is the same or represent the gradient, and also c represent the y-intercept. So that's how we get the gradient. But one will be asking, what is the gradient? What is even doing? What is it that we are doing when we talk about the gradient? So the gradient is actually what we usually do every day. We just don't know and we don't relate. But every time you go through a hill, some sort of a hill, or you are climbing stairs going up, you are actually using a particular gradient going up. So that's why we say it's literally the steepness of what it is that we are doing, and it's literally showing the direction of where you are going. So if I'm going climbing step up, I am going with a particular gradient. If I go down, then I also go with a particular gradient. So we're going to go through all that together in this today's lesson. Okay. So how do we calculate the gradient? I've put some examples that are already worked up. So every time you are given 2 points, you need to know how to calculate the gradient. So in your space, if they've given a point, say for example, we had point where there is 2 and 3, as well as another point worth 6 and 11. So every time, if you recall very well, we did say that every time we write a coordinate, we write it in terms of x and then y, because x is the input and then y is the output. So that's how we write it all the time. So we need to have x before we can get y. So in this case, we have represented our numbers in terms of x and y. So when we represent it, we do say that 2 will represent our x1, for example, and then 6 will represent the x2. So do you see where I'm writing the numbers? I'm writing them as superscript right at the bottom, right? So you can see how we are writing them. It has to be right at the bottom. You don't put it together with the number, but it has to be at the bottom of the number like this. So if I choose my 2 to be x1, that means my 6 will be x2. And then the y in 3, I will have y1, and also on the other one, the 11 will be y2. You cannot have them otherwise, unless what you can also do will be, if you choose to have 6 as 1, then it means you're going to have your 6 as x1, but your 11 will therefore be your y1. So you cannot have x1 and y2 in one coordinate. That is very important, and you need to always remember that. You can't have x1 and y2 on the same, but you can have x1 and x2 in one coordinate, and that's what we are trying to demonstrate here. So because we have already said this is our interpretation, when you substitute into your formula, m equals our y2, which our y2 is what? It's 11. So hence we have 11 first, and then we subtract by our y1, which is what? Which is 3. And then we divide all that with our x's, which is x2 minus x1. Right? So that is more like you have your gradient calculation in that way. You can quickly put that in the calculator, or you can use your mental math. 11 minus 3 is 8. And also 6 minus 2 is 4, which will literally give us what? Answer to be 2, because 8 divided by 4 equals 2. So therefore, the gradient is going to be a positive 2. So that's how we calculate the gradient here when we have 2 points, and that's what we have. So it can be a point. This point has to be on the same straight line. In other words, you cannot calculate the gradient of different straight lines or different lines or with a non-straight line particular graph. So it has to be a straight line for us to be able to draw. Hence we said find the gradient of the line passing through points. So that one line have 2 points that we are calculating the gradient from. I hope you guys have got that and you have understood it very well. So with that gradient being calculated, like that, and I've showed you how you can then calculate the gradient with the point, I'm going to leave this together with these examples, that the activity that we have here, because I want you to try and calculate. As you are trying to calculate those, I want you to put your answer, just the answer, into the chart so that we can be able to work on it together. So I'm going to give you a few minutes for you to look into that and use the same method that we have just used with your gradient formula equation, as well as the points that are given to you for you to be able to calculate the gradient. I'm very sure that you can be able to grasp that. Let me just put the formula for you here so that you do remember what the formula look like. So m equals, let's use another color. M equals, we said, we can say y2 minus y1 divided by x2 minus x1. So you can use the same method for you to calculate the gradient of that. So I'm going to give you a few minutes for you to go through that. Yes, grade 9s. I'm very sure that you guys have started, and let's do it together now, step by step, and see how far we can go. So with the number A, which is, we are given the points 1 and 2. And also we are given the points 4 and 8. So let's work on that together and see how we're going to label our x1, x2, and our y1, y2 with this coordinate. So let's copy that down. So usually it's very important that you you label your coordinates according to how you want to use them into the equation. So here for me, I'll have my 1 as x1 and my 4 as x2. Also have my 2 as y1 and my 8 as y2. Remember, these are coordinates that we are going to use. So from there, I'm going to just write my formula so I don't forget it. So m will be equals to y2 minus y1 divided by x2 minus x1. So that's how we're going to start, right? So as we have that, let's substitute. What is our y2? We said it is 8. So we're going to have 8 minus 2, and then our x2 is going to be 4, while our x1 is 1. Then we're going to just use a calculator, or we can just use our mental math. 8 minus 2 is 6, and then 4 minus 1 is 3, which will give us the answer 2. So that means that our gradient will therefore be 2. That's what you do to calculate this gradient, and you can always keep on doing it like that. With all these questions, we're going to do the similar thing, but let's try number B in a very quick way of writing it. So let's see if I have my x1 to be negative 2 and my x2 to be 3, while my y1 is 5 and my y2 is a negative 5, like that. So when I write my equation or my formula, m equals y2 minus y1 divided by x2 minus x1. Let's substitute. What did we say our y2 is? We said it's going to be a negative 5. We write it with the sign, so we do not leave our sign behind. Okay, so we're going to minus, but then that is minus 5. So we don't have to write a plus, because a negative multiplied by a positive gives us a negative. So that's why we just write that minus there. Divide, our x2 is 3, and we are minusing by minus 2. Remember, I always said when I get married, I did go with my surname. Even though I changed the surname, at Home Affairs, my surname still stays the same. So this person must go with their surname. Don't leave the people's surname there. Ensure that you write the surname there, which is minus 2. So a negative 5 minus 5, that will be a negative 10. And then we have 3 minus minus 5. Remember, a negative times a negative will give us a positive. So that will make it an addition. Then we'll have 5. We keep the negative because it's 1. And then 10 divided by 5 will give us 2. So then our gradient, therefore, will be a negative 2. Right? I will explain to you guys what is the difference between a gradient that is a negative and a gradient that is a positive when we get to it. Number 3, which is the C1, we have a 0 and a 0. So we label the same way. We just have to go there and say this will be my x1 and this will be my y1. That will be my x2 and my y2. You always just write it like that. It will help you. For you to get it right, just always fill it in, and then you write down your equation all the time. Do not ever say, I have seen the equation many times, I can't write it again. You need this equation because it's going to help you when you substitute. Okay, what is my y2? My y2 is 0, and also my y1 is 0, right? What is my x2? My x2 is 5, and my x1 is 0. We still substitute. We don't disregard because we have a 0, because guess what? In maths, 0 is part of numbers, so we write it down as a number. 0 minus a 0 is 0, and a 5 minus a 0 is 5. Now, we are in the maths. Even if, excuse me, even if you can take your calculator and you say 0 divided by 5, the answer will still be 0. Because anything that you divide 0, you'll just always have the answer as 0. So that means that your gradient is therefore 0. We're going to explain again that why do we have the answer to be 0? What happened when we have the answer being 0? But I need you to tune in for that to be shown. Let's do the last one. We have number D. With number D, so we're going to just keep on showing it so that we know, keep on labeling them. So x1 is 2 and y1 is negative 3. And then x2 is 2 and then y2 is 4. Right, so let's go. We have our gradient equals y2 minus y1 divided by x2 minus x1. Right, so let's substitute. What is our y2? Y2 is 4. We subtract a minus a 3, just like that. Then we divide all of it with our x2, which is 2, and then we minus our x1, which is also 2. So let's see what we get. That is going to be 4 minus 3, which means we have a negative times a negative, which will give us a positive, and that means we're going to add them and we get 7. So that is going to be 7 divided by a 2 minus a 2 will give us 0. If you do this in the calculator will tell you that this is an error, just because a calculator could not have written the maths language, which is called undefined. We don't really have an error. It's just that we cannot define this. We don't know what it is. So then the answer, therefore, is just undefined. So we can't define this one. We just have to call it undefined. Not an error. Please, even if your calculator is giving you error, do not write your answer as error. So you just have to know, if I have a number that I'm dividing by 0, or a variable I'm dividing by 0, an equation divided by 0, an expression divided by 0, that particular answer will be undefined. And that is very crucial for you to know and remember. Okay. I'm very sure that for now, you guys have mastered that and you have seen how it has been done. And then you can be able to put questions on the chat for us to see and be able to assist you whenever you need help. This time around, gradient calculation should be very easy for you, right? So you can go to many questions and get it. Our Platinum textbooks have a lot of calculations, which most of the explanation that I will be now doing graphically are in Platinum textbook. So we do have our Platinum, which looks very colorful like that. And this book have a lot of examples, a lot of ways to do it that can explain to you in how did we calculate or how the calculations were done like that. I'm very sure that you guys will be happy to go there and then you check. So when we were busy here, you would see that we had different types of gradients. So I'm going to go back a little bit to them. So if you see here, our number A, when we were calculating the gradient, we had the answer to be 2, which simply means that our gradient is positive, right? So if the gradient is positive, that means that if we represent it graphically, that means that our graph or our slope, it will be in this manner, where usually other people will just say it does this. So it's you open arm like that. My left hand does it very well. If I open it like this, that's how my graph will look like. Then that means that my gradient is positive. So mathematically, we just say gradient is greater than 0. So every time you have an equation that you have a gradient that is positive, or your value of m is positive, that means if you have to draw the graph, which will be our next lesson, you would have drawn the graph in this manner. So I'll show you that way in the next lesson when we are drawing the graphs, since we are not drawing now. So that's the first explanation. Then when you go to the second one, you would see that our answer, therefore, was a -2. So the fact that we have a negative, if you do it in real life, so when you're going up like that, you're going up the stairs, you're positively going up. This is how you are going. But when you come down, you are negatively coming down. So that's what is happening here. So as much as we want, when the value of x is increasing, going from the negative to the positive, the value of y is going down. So the graph starts always on the left. You draw it from the left to the right. So as x increases from the negative to the positive, our graph is going down. In other words, our values of y, the output, are all going down, which is the opposite of the positive one. So that's one of the others. Then we have the slope whereby you had m or gradient equals 0, which is similar to what we have here. So if your gradient is equals to 0, that simple means that you have a horizontal line that is parallel to your x-axis. Remember, this x-axis is our line y equals 0, which we will do quite a lot when we are drawing the graphs, and we have done it in the first lesson as well to see how parallel lines look. So this equation that we have here is actually just an equation that we'll call x equals, y equals a negative 4, right? So that's a y equation. So we're going to call this one y equals a negative 4, since this is parallel to our x-axis, which is the line y equals 0. So every line that is like this parallel to the line x-axis, we call it y equals something. So this will be y equals a negative 4, as much as this y equals 0. And that is where we have our gradient being 0. Okay. Our other part is where the gradient is undefined, where you cannot define the gradient. You can see that that is where you have a vertical line that is parallel to our y-axis. And our y-axis, literally we call it x equals a 0 line. Our y-axis is called x equals 0 line, which means that the line that is parallel to it, it's called x equals a whatever number. In this case, our x will be equals to 2. But with this one, when it's a vertical line, then m is undefined. Gradient is undefined. When it's a horizontal line, the gradient equals 0. And when you step up like this, you're going up like you're climbing a ladder, then your gradient is positive. Your gradient is greater than 0. But if you look like you're going down, as x increases, y decreases, then our gradient is a negative, meaning that our gradient is less than 0. I am very sure that you guys have learned and have seen that. And here I just showed you another description of how the gradient are shown. So I want you guys to just look at that diagram as you consume and absorb everything that we have learned just now about the gradient. Let's recap. So you have learned how to use a formula to calculate the gradient. You have learned how to interpret the gradient just by looking at the graph. So you look at the graph and you can tell this gradient is going to be positive, this gradient is going to be negative, 0, or undefined. So you have seen that, you have learned that. Now I want you to just breathe, take a very deep breath and remain a little bit, like few seconds. Then we come back to show you how can you then read the gradient from the graph, provided you are given a grade. Stay tuned. There's always my director somewhere there who's saying that I must complete sentences. So I really believe that you guys could read it there, but let me complete because there is a ear, kind of a say in my ear saying that you guys won't understand this. So let's finish undefined. That is going to be undefined. Let's just write that before we move on. So that is undefined value, right? So we don't have a solution to that one. But anyway, since I have promised you guys that we're going to learn quite a lot today with all what we have according to what the gradient can have. So here's an example where you would be given a slope. You can still use your point to calculate, but there's no need really. I will show you we can calculate and also we can count, right? So if we had to calculate, you would have come and say, I have my X and I have my Y. So if I come here and I say this is X1 and that is Y1, that is X2 and that is Y2, according to how we have been naming them. And I calculate or find my gradient will be, remember, to write the equation y2 minus y1, and we have x2 minus x1. Let's substitute. We said y2 is 6 and y1 is 4. Again, we said x2 is 2, and then what is x1 is also going to be 2. That's wrong. Okay. Let's see. Our x value is 2 there, and our x value there is 4. Right, so that is going to be, x2 is going to be 4. And that will be 6 minus 4, it's going to give us a 2. And the 4 minus 2 is going to give us a 2, which means that our gradient is going to be 1. Right. So when the gradient is going to be 1 there, can you see when you use a formula and when you count just by going to the left, to the right and up according to what you have. So you always move from what you have. So we move from the point and then we count. So even if I go and I count 1, 2, 3 and I move 1, 2, 3. Do you see it still give me 3 divided by 3? So this will be my x and that will be my y. So y, change in y will be the first one, which is the 3 I have here. And then the change in x will be the 3 I have here. It doesn't matter really how many times you count. Even if I start on this point here, which I have 2, if I count 1, 2, 3, I will stand here. And if I have to count going up, I'll also count 1, 2, 3. So it's still going to give me the same gradient with whatever point I have into this diagram. It doesn't matter where I start, for as long as I start where there is a point, and when I count, if I'm given a grid, it's easier for me to count using the grid. Just make sure that when you are counting, you start where the grid is intersecting with something. So that's how this is calculated here. If you check, you would see how they have done it here. They just have went and counted according to their point. So in point A, we moved 1, 2. And then in point, when you are on point, what is it? Point, when you are on here, on where there's 4 and 4, you just move up 1, 2 as well. So that's why it becomes 2 divided by 2, which gives us the answer to be a 1, which is literally the same. So this is many of the examples. You can just go to our book and you'll find them. These are just extra quiz that you can take and learn more about. I just needed you to put it on the chat to say if you have to calculate the gradient, what does the gradient mean when you have a negative, and what does the gradient mean, or which one is steeper than the other. Put these answers into our chat and ensure that you take the screenshot so that you can be able to respond the questions there. If you are busy doing this question and you got stuck, go to our textbook. In page 207, Platinum book, you'll be able to find many, many other questions that can also help you to consolidate both the questions that we have done from all types of graphs. But if you're still stuck, reach out to our friends and ask more. We have Maski waiting for you to help. If you don't have the number by now, please write them down 072 091 0388. That is Maski number for WhatsApp. But still catch up on Maski TV every Wednesday for grade 9. You just have to make sure that you stay with us, same time, same place, with Teacher Thandi and Maski TV. See you next time. Bye.
And now we enter our next exciting chapter with the launch of Maskiverse, an inspiring trio of innovations, our AI-powered learning companion, captivating TV content, and a vibrant playground for interactive learning, and our own dedicated app, all coming together beautifully to deliver learning outcomes through technology.